Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In this recording, we'd like to show the quick setup on large parts that are enabled today and also working quickly with HSR and HSM, especially on large parts. If we take a look at the part that we have on the screen, you'll see that we have a very large part with many different surfaces on the part itself. Now, we'll start our SolidCAM project by creating a new milling project, and we'll accept this. Now, we'll go and create our coordinate system. Previously, when creating a coordinate system on large parts, this would take actually a long time just to create the coordinate system. The improvements that we've done inside SolidCAM itself allows us to actually create the coordinate system very quickly. If you note, all I'll do, just as in before, I'll click on the surface, and the coordinate system is actually here within a few seconds as opposed to a few minutes in many cases. As you can see, the coordinate system is already here. If I want, I can always flip it around my Z just as in before, do anything I want, and we'll just accept it the way it is. We'll continue on with the part, and I've already created my coordinate system. The improvements that we've seen over here, by the way, is approximately 4 to 5 times quicker than what it used to do previously. The improvements have not only stopped there, but they've also continued on with creating our stock and target. If I were to go and create a stock, now in my particular settings, I've created this automatically. But let's actually just unselect all, and I'll just reselect by clicking on the surface over here. You'll note how quickly the creation has been done on the part itself. The same thing is true with our target. If I were to go into target, again, let me delete everything that I have over here, and I'll just click on the part itself. As you can see, the part has been selected. If I want to add anything else, I can just add anything else just the way I want to do it. You can see how quickly this has been done. All I have to do now is just click on OK, and we're ready to start working on this part. Done very quickly. Now, before I continue with the part, I'd like to go into my SolidCAM settings and explain a new option that we have here for updated stock. If you'll note now in updated stock, we have two situations over here. We have one called regular and one called special for HSR HSM. Regular is used when you have operations over here that are not only HSR and HSM, but can be a combination of 2.5D, HSR, HSM, iMachining, 5-axis. When you have multiple types of operations over here, you use regular. However, if all the operations that you will be using over here will be HSR and HSM, then we've added a new option here called special for HSR, HSM. This will actually speed up the calculation for your rest machining on parts, and especially on large parts, such as shown on over here. Now, what I'd like to do on this part to demonstrate how quickly we work over here, is I'd like to do 4 different operations. I'll be using first our HSR HM operation for taking a rough cut on the part itself. Then I'll be doing 2 separate HSR rest roughing operations, and then I'll be doing one particular finish operation. We'll first start with our 3D HSR, and we use the option called HM roughing. This is a relatively new option inside our roughing operations. This can be used on just about any single part as it has different types of options. We'll go into more details on this part on a different recording that I'll do specifically on HM roughing. Next, we'll choose our tool. I'm going to be using a 16mm end mill. My constraint boundaries are going to be the entire part, and I'm going to be working external as I want to work on the entire part. Now, let's go into our passes. I'm going to have my wall offset set right now at 1 millimeter as well as my floor offset. And let's stop for a moment and talk about our tolerance. Now, when working on a large part, and especially when working with large offsets such as this, I don't have to leave a small tolerance as shown over here. Since I'm leaving that much material, I can actually give a larger tolerance such as 0.1. By doing so, the calculation actually later on, since it doesn't have to work in such a tight tolerance, will go a lot quicker. Let me put my step down now at every 3 millimeters, and note all I had to do right now is just work on my wall offset, my floor offsets, my tolerance, and my step down. The rest is done automatically in HSR by formulas built in. We'll run our calculation, and you'll note that I'm going to let the calculation run now from the beginning to the end to show how quickly it runs on quick parts such as this one. Previously, in other parts, this would actually take quite a long time to calculate. However, since we have a new way of calculating inside HSR and HSM, the calculation is done very quickly. As you see, we finished the calculation already on this large part. And if I run my simulation, we can see our toolpath running along over here. Now, let me stop this for a moment. You can see the actual toolpath being created over here. But if I want, I don't have to actually run the entire toolpath. All I have to do is just by clicking on this box over here, the toolpath will pop up immediately because preview is also calculated as I'm doing the calculation of the part itself. Now let's continue on the part, and we'll continue with our next operation. Now when we do our HSR rest roughing operation, I'd like to do it 2 different times. Once, if we take a look at our settings, I'm going to have my updated stock calculation set at regular, and then the second time we'll show it to you and at special for HSR, HSM, and we'll see in a moment what the difference is between the two of them. Right now, I'm just going to leave it at regular. If I go into the operation now itself, I'll just do save and copy, and I'll change my HM roughing to rest roughing. I'll change my tool, and in this particular case, I'm going to use a new tool of a bullnose type, and I'll use a 10 millimeter bullnose for the part itself. My constraint boundaries will be the same. My passes, we have again our wall offset, my floor offset, same tolerance, nothing has changed over there, and I'll put my step down at every 1.5 millimeters. And now let's run our calculation. Note when I start my calculation, it starts the fastening process of the part itself. And you'll see that it'll take a certain amount of time to calculate this part. I'm actually going to let it run now the entire time so we can see the entire process and see exactly how long this is going to be taking. Note, again, we have the fastening process as it's done in the beginning of this part. And now it's actually doing the updated stock for the operation. Now it's bringing up this window for the contour rough passes, calculating all of these inside over here as well. And you can see exactly what's going on in this part itself. When it finishes calculating this, it'll open up its next window, and we'll see this in a moment or two, as it continues on with its linker as shown over here. The roughing linker calculating that as well. And after it finishes this, as you see, it's moving up in the rows over here. It's creating the end toolpath. And you can see exactly how long this took. Now let's just take a quick look at the toolpath, but instead of actually running the toolpath, I'll just click on the box over here so we can see this very quickly. You can see all of the approaches and retracts and the finishes on the part itself for the rest roughing. But now let's go back into the part itself and change my settings. In my settings, I'm going to go back and change my updated stock to special for HSR HSM and accept that. I'm going to go into my CAM part, and I'm going to actually do a cleanup of my CAM part to get rid of any of the excess stuff I've done before, so we can actually start cleanly on the part itself. Now let me go back into the operation, and I'm going to recalculate the part. This time you'll know when I start the calculation, it's again building the STL for the part itself, but you can see now how quickly everything is done inside this one box itself, much quicker than it was working on in the previous time I did the calculation of the part. Now, if we were to compare this to a large part, where previously it used to take 1 hour to calculate a part in many cases, it will now take about 25 minutes instead. A large saving on time as far as calculation of the parts. So when doing parts where you have basically only HSR and HSM operations, we highly recommend using this option to make your calculation go a lot quicker. As you see, we're already finished with the calculation, and you can see how much quicker it was than we did before. Again, I'll show the calculated toolpath, and you can see now the actual calculated toolpath as it's done in this particular case. Now, I'd like to continue with another rest rough operation, so I'll go inside my operation over here and just do a simple save and copy. This time, I'm going to use a smaller tool, but use all the settings that I had last time. This time, the tool that I'll be using will be a ball nose tool of 6 millimeters. My constraint boundaries will stay the same, and in my passes, I'll keep my save wall offset, my floor offset, my tolerances. This time I'll put my step down at every 0.75 millimeters, and then I'll run my calculation. Note, this time when I run my calculation, it's already loading it with the actual calculation of the part. In our previous, with the regular option, it shows the calculation first of the remaining material and then goes down to these parts. This is already done in here, so therefore you're wasting a lot less time as far as the calculation goes. The calculation is much quicker, as you can see, and we can get results a lot faster. I'm going to let the calculation run until the very end. And after I finish this part, I'm actually going to run my simulation using Solid Verify. When we use Solid Verify, we'll show you actually the way to do this properly in Solid Verify by using Solid Verify for 3D in this particular case, especially made for large parts. We'll just let the calculation finish up over here. As you see, it's about 64%, 66% now on the thing. Now it's going on to the linker, linking the toolpaths together, finishing that calculation. And since this is a large part, it is taking some time, but the time that it's taking is a lot quicker than it did previously. Now, as it's getting close to the end of its calculation and calculating its toolpath, we'll run the simulation, as I said, using the Solid Verify for 3D. Now, let's run a simulation, and then this time I'm going to run the simulation on the entire part, and I'll use the option of Quick Solid Verify, specifically made for 3D operations. Using Quick Solid Verify, you'll note that the simulation runs very quickly on these parts. And as you can see, it's literally zipping through the simulation on the part itself. We're already in our second operation, and yet as you can see, it's still moving very quickly on this part, as it takes large steps in between from one point to the other as we view them. This allows for very quick Solid Verify on large parts. Let's end the simulation at this point, and we'll go on to our next operation. Now, let me continue and just do one more operation on this part using an HSM finish operation of linear. And we'll also see how quickly it calculates and works on a large part such as this. So I'll start my HSM operation and I'll use the option of linear machining. I'll be creating a new tool of a ball nose of 6 millimeters, and I'm also going to add a holder to the tool like this one over here. I have my boundaries. I'm going to work around the center boundary of the part. And in my passes, if I want to do a semi-finish, I can do that as well. I'm going to have 0.1 millimeter for my wall offset for my semi-finish. And since I'm leaving 0.1, I don't need such a tight tolerance. Even 0.2 is relatively tight tolerance for this kind of a finish. So I'm going to change my tolerance over here to 0.05. And let's just do a step over of every millimeter. Now, it's also recommended many times that when working linear on big parts such as this, you should have a defined angle of approximately 45 degrees. This will actually give you a nicer finish on the part itself. Let's run our calculation, and as you can see now, again, it's building its STL for our finish cuts, and once the finish is doing that, the calculation itself is going very quickly as shown over here. Now, when we finish this calculation, we'll also take a look at the simulation using our host CAD. As you see, the calculation has finished already. Taking a look at the simulation, you can see that we're getting that nice finish in the 45-degree angle over the surface, giving for a nice smooth finish on the part itself. For more videos on SolidCAM Professor, please go to our website, www.solidcam.com, and look for the tab called SolidCAM Professor. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.